a visitor from outside our solar system, behaving like nothing we have ever seen. On October 4, 2025, NASA's Perseverance Rover on Mars captured an image of an object that defies all explanation. The image shows something structured, massive, and completely unexplainable. This wasn't a blurry photo of a distant comet, it was a clear anomaly that brought the scientific community to a silent halt. Within hours of its internal analysis, the official data streams went dark. What did Perseverance really capture? And what has NASA discovered that they are not yet ready to reveal? Let's explore this together.
The accidental photo.
How do you discover something that shouldn't exist? Sometimes it happens by complete accident. It was Sol 1643 of the Perseverance rover's mission on Mars. As another Martian evening fell, the rover's right-side navigation camera, or NavCam, turned towards the horizon for a routine terrain check before its nightly shutdown. But when the frame reached mission control at the Jet Propulsion Laboratory, something was wrong. A faint blur, barely a dozen pixels wide, hung in the sky where no star should be. Initially, imaging scientists like Justin Mackey, who leads the Perseverance imaging team, might have logged it as an imaging artifact, but the blur remained in subsequent frames, shifting slightly. The image was released to the public archive, and amateur astronomers noticed it first, realizing the blur sat exactly where the interstellar object 3I/Atlas was predicted to be. That was thought to be impossible. The rover wasn't meant to be an observatory, yet it had captured an interstellar traveler from the surface of another world. The sheer statistical improbability of a geology rover looking at the right place at the exact right time was staggering, a detail that would later fuel intense debate.
Confirming the visitor.
How do you turn an anomaly into a fact? Once the internet started buzzing, the pressure was on for official confirmation. Engineers at JPL, under the guidance of orbital dynamics experts like Davide Farnocchia, began to reconstruct the rover's exact positioning. They cross-referenced every piece of data: the mastcam Z's elevation, the navcam's exposure angle, and the star tracker logs. Every single data point confirmed the impossible. The camera had been aimed at the precise segment of Martian sky where 3I/Atlas was traveling. Its distance at that moment was calculated to be a mere 28 million kilometers from Mars. The faint drift of the object between the frames even matched its calculated motion relative to the planet's rotation. The realization sent shockwaves through internal channels. Planetary scientists then called for checks from orbiters like the Mars Reconnaissance Orbiter and the Trace Gas Orbiter. Both registered a subtle optical fluctuation in the same quadrant of the sky. While not as clear as the rover's photo, it was enough to verify a presence moving at an interstellar velocity of nearly 200,000 miles per hour. The anomaly was now a confirmed target, shifting the mood at mission control from skepticism to a palpable sense of awe.
Reconstructing the image.
What secrets can you pull from a dozen pixels of light? With confirmation secured, JPL's imaging division began the slow, meticulous work of reconstruction. The raw navcam frames from Sol 1643 were reprocessed pixel by pixel. Under the careful analysis of imaging specialists, perhaps someone like Dr. Paola Pinilla, whose work involves teasing details from cosmic dust, the team stripped away atmospheric interference and compression noise. They stacked the images to recover lost light. They expected a sharper dot, but what emerged was staggering. The blur transformed into a distinct, elongated object drifting against the fixed stars. When scaled to its known distance, its apparent length stretched for several kilometers. But another anomaly emerged. The object's light curve was inverted. Instead of fading as the viewing angle increased, its brightness rose. It was reflecting light back toward the sun, a phenomenon never recorded in a natural comet. This wasn't a glitch. It was a measurable contradiction that hinted at something truly alien. This single detail became the first piece of hard evidence that this object wasn't just a comet, but something that fundamentally challenged our understanding of physics.
Light defies rules.
What if something from outside our solar system doesn't play by our rules of physics? The inverted light curve was just the beginning. The next step was to understand why the light from 3I/Atlas behaved this way. Using polarization analysis from both Mars orbiters and Earth-based telescopes, astronomers began plotting the object's optical signature. This work, in the hands of a polarimetry expert like Dr. Ludmila Kolokolova, would reveal the impossible. Normally, light bouncing off cometary dust becomes positively polarized at larger viewing angles, but 3I Atlas showed an extreme and constant negative polarization, a reading never before seen in any celestial body. This implied the particles surrounding it were not fluffy ice grains, but dense, irregular metallic structures. The data even suggested the dust grains were like microscopic shards of crystalline glass or oxidized metal, scattering light in chaotic directions. When the results were independently verified, it was official. 3I Atlas displayed the strongest negative polarization ever recorded. Sunlight itself was behaving differently around this visitor, as if passing through a completely foreign medium, forcing scientists to confront the possibility that the object's composition was based on a chemistry unknown to us.
The backwards tail.
Comet tails are supposed to point away from the sun, so what does it mean when one points the wrong way? When the next round of high-contrast images came in from the Mars Reconnaissance Orbiter, the strangeness became visible. A faint linear streak was seen emerging from the object's sun-facing side, not trailing behind it. This structure, which comet specialists like Dr. Geraint Jones would analyze, resembled a thin beam of dust brightening toward the sun. Some might call it an anti-tail, a rare optical illusion. But this was no illusion. The beam persisted across multiple observations from different angles. It was real, stable, and symmetrical. Spectral measurements showed the beam was made of micron-sized silicates and oxidized metal grains, far denser than typical comet jets. For the beam to remain so precise, the object's nucleus had to be extraordinarily cohesive and heavy, likely with a metallic core. Every new model led to the same conclusion. 3I Atlas was thousands of times denser than any known comet, emitting matter as if through a carved, controlled corridor. This suggested a focused, sustained release of material, a process entirely foreign to natural comets.
Solar blast.
What happens when an unstoppable force meets an immovable object? On October 6, 2025, just 2 days after the rover's image, the sun erupted. A massive coronal mass ejection, or CME, blasted from an active region and raced outward at nearly 2 million kilometers per hour. Solar physicists like Dr. Holly Gilbert at NASA tracked these events, and their models predicted the CME's front would cross the orbit of Mars exactly where 3I Atlas was traveling. This was a direct hit from one of the most powerful forces in the solar system. Across 3 observatories, tracking feeds flickered as brightness readings from the object spiked for 6 hours and then collapsed into absolute silence. Perseverance's own environmental sensors on Mars recorded a surge in electrostatic charge, a clear sign the shock front had arrived. When the CME passed, 3I Atlas was gone. No optical trace, no thermal signature, nothing. It was as if the sun itself had reached out and wiped the visitor from the sky. The initial consensus was grim. They believed they had just witnessed the complete disintegration of a unique celestial body.
The disappearance.
How does something just vanish from existence? For 2 agonizing weeks, astronomers searched every scheduled tracking window for 3I/Atlas, but there was nothing. It was as if the object had blinked out of reality between frames. The timing was just too perfect. The CME's arrival and the comet's disappearance were separated by less than 8 hours. Analysts initially blamed solar glare or its increasing distance, but honestly, the numbers just didn't add up. Then, one instrument caught a final ghostly echo. A brief, half-second polarized flash was detected by ESA's solar orbiter, a pulse of reflected light moving opposite the CME's flow. At the time, project scientists like Dr. Daniel Miller might have classified it as a non-correlated event, but later reviews would show its origin aligned perfectly with the last known vector of 3I/Atlas. It wasn't a death cry, it was a sign of survival. The object hadn't been destroyed. That single, fleeting flash became one of the most hotly debated pieces of data, turning a story about destruction into a profound mystery about resilience.
Impossible mass.
What does it take to withstand the full force of the sun and not even flinch? When orbital tracking finally resumed, the first surprise wasn't that 3I Atlas had survived, it was that its path had not changed at all. Even after being hit by a massive CME, its trajectory remained perfectly stable. Celestial mechanics experts like Dr. Renu Malhotra would confirm that there was no measurable drift, no sign of acceleration or deflection. This stability became the key to a new mystery. The brightness spike during the solar blast suggested jets of gas had been released, and the recoil from that alone should have nudged the object off course. The fact that it hadn't moved meant its mass was vastly greater than anyone imagined. New models from both NASA and the European Space Operations Center were run. To maintain that level of inertia, the object would have to weigh more than 33 billion tons, 1,000 times the mass of a typical comet. Its effective density was closer to solid iron. It was a true astronomical paradox, a body massive enough to ignore the sun, yet delicate enough to shed dust without recoil. This invalidated nearly every theory that described it as a natural comet.
Martian chemistry.
What if a visitor from another star system felt strangely familiar? As spectral data from the Trace Gas Orbiter and ground-based observatories arrived, a new clue surfaced, hidden in the light itself. The thin halo of dust around 3I Atlas contained unmistakable signatures of iron oxide, silicate minerals, and perchlorate compounds. At first, astrobiologists like Dr. Brian E. Horgan assumed it was contamination from Mars's upper atmosphere, since the rover's image was taken close to the horizon. But follow-up readings from Earth showed the exact same pattern, independent of any Martian influence. The conclusion was unavoidable. The dust surrounding 3I Atlas contained the same oxidized minerals that give Mars its red color. Its composition matched not the chemistry of a comet, but the crustal rock of a terrestrial planet. This meant 3I Atlas might not be a frozen remnant from deep space, but a planetary fragment, a shard of a long-lost, Mars-like world. It was as if a piece of another world had drifted across the Martian sky, carrying the same minerals as the planet below it, suggesting that Mars-like exoplanets not only exist, but their fragments travel between the stars.
Geometric patterns.
Is there a difference between coincidence and choreography? Once the orbital reconstruction was complete, analysts noticed a pattern that defied probability. 3I Atlas wasn't entering our solar system from a random angle. Its inbound path was aligned with the ecliptic plane, the same thin disk where all the major planets orbit. No known interstellar object had ever done that. Furthermore, its route between August and October 2025 intersected the orbital paths of Mars, Venus, and Jupiter in a sequence of near-perfect harmonic intervals. The odds of this happening naturally were calculated at less than 1 in 10 million. Then came the most chilling discovery: tracing the object's vector backward, as a researcher like Seth Shostak at the SETI Institute might do, placed its origin astonishingly close to the source region of the 1977 WOW signal. The alignment wasn't perfect, but it was close enough to reignite old debates. It looked less like coincidence and more like a planned trajectory. The data felt uncomfortably ordered, moving the discussion from the realm of natural phenomena to a place few scientists were willing to go. In the days that followed these discoveries, the public updates stopped, mission logs went dark, replaced by placeholders marked data under review. The raw image stream from Perseverance skipped Sol 1644 entirely. It wasn't censorship, it was caution. The data didn't fit any existing models, and no one was ready to explain why. A single photograph from the surface of Mars has forced humanity to ask whether the universe is watching us as closely as we are watching it. So, what do you think this object was? A planetary fragment, a cosmic anomaly, or something else? Let us know your theories in the comments down below. And don't forget to like, subscribe, and hit the bell icon for more on the mysteries of 3I Atlas. Thank you for watching Future Facts.